Today we are going to discuss about the grid. What is meant by grid? What is the reason of grid failure? And what was the scenario that was happening in Mumbai on 12th October? That is about the collapsing of the grid. So that is called as blackout in Mumbai. Okay, so let's start. So every electrical engineer know how the electricity come at your home. So you know that there are the three main entities like generation, distribution, and transmission, right? So here the generation, this one, then the middle one is nothing but the transmission. Transmission means it will carry the power from generating station to the distribution station. After the distribution station, that will reach to our home and industry, right? So the meanwhile networks, right? The meanwhile network between the generation to the distribution, that is involved a lot of equipment like transformer, protecting equipments, and accessories like foundation, that is tower foundations and cabling and ACSR conductor. All these things are come under the transmission sector, and these all things that will carry the power from the generating station to the distribution is referred to be as a grid, right? And that is called as grid. So these things, the next one is nothing but this power flow that will flow from generating station to the distribution station, right? So that will control by some authorities in India, that is under the government of control. So there is a one central authorities like NLDC, that is National Load Dispatch Center. This one is nothing but the NLDC, right? National Load Dispatch Center. So this NLDC, which having the control over the each regional load dispatch center. Like in India, there are five regional load dispatch center in Mumbai, Delhi, Bangalore, Kolkata, and Shillong. That is western region, northern region, southern region, east region, and northeastern region load dispatch center, right? So each again regional load dispatch centers again are monitored. They are having the control over the each SLDs of respective states. Like in Maharashtra, they are in Maharashtra, the load dispatch center of state, which is in Kalwa, in Gujarat, which is in Vadodara. They are having the control at their respective SLDCs. Along with that regional SLDCs, which is in the Mumbai, right? Right. So in western region, there are the five states or and union territories are there, right? Same thing like that. So this is the sequence of the control of the power flow by the governments, right? So this is responsible, these SLDCs are responsible for maintaining the frequencies, maintaining the power matching, that is the generation and the demand they are matching for from here, right? Here also the they these peoples are seeing all the generation, all the demands. So they are confirming, alarming the each individual generator to increase or decrease the load or demand. So this is the important parameters in the power flow to maintain the power, to maintain the generation and distribution, right? So for which it is responsible. So next one, so this is nothing but the why the grid fails. So we know that the grid is there. So how the grid is fails? Basically, there is a lot of generator and a lot of loads we are having. So so generator generation and the load power, that has to be matched. If it is not matched, then what happen? Then there is a possibility of frequency increment or decrement, right? So let's that we will see in next slide. Overloading of generating utilities also lead to the grid failure. So because of the grid failure, that will outages that results in the power systems, or some remedies are there for avoiding this load shedding, but it is not that is not appropriate. Like next one is nothing but the how this is the grid stability according to the CERC, Central Electricity Regulatory Commission. They are decided the frequency band which is of which is of in between 49.95 to 50.05 at the end of the 2020. So next one is nothing but the what happen whenever the load increases and frequency drops. We know that we have to match the power from the generation to the distribution. But suppose we know that every this is the formula which is basically the basic formula of the generator synchronous machine. Ns is nothing but synchronous speed equal to 120 into a frequency divided by pole, right? So we know that whenever the load increases, then what happen? As load increases, the generator has to increase its speed. But at the time what happen, the rotor having its own inertia. Whenever the load increases, the rotor inertia is also more, so it will decrease its speed. As the speed is decreases, then frequency is drops. That will be the indicators, that something is happens in the system. So there is a low frequency relay is there which will tripped, because we have to set the frequency in the limit of 49.95 to the 50.05. So this is the reason, this is the one thing that is responsible for the frequency drops. Same things for the frequency increment. But this scenario is for more than some time, then it will leads to the grid failure. Somehow in today's scenario, all the generating station have the facility to cope with this problems for the shorter duration. But if it is happens for long duration, then there this leads to the grid failure. So this is the way by which the grid is failure managed. There are the two voltage control. There are the two remedies. One is the voltage control and one other is the frequency control. In voltage control, the whatever the difference in the voltage that is get sensed, and that will apply to this generator, and according to that it will generate more. Same things for the frequency. Deviation in frequency is sensed. If it is plus or minus, that is applied to the turbine input. As turbine input, we know that steam pressure or water pressure or whatever is there, but it is pressure, right? So which is in the form of kinetic energy. So this is we have to manage, and that will given to the input to the turbine, and turbine will take a necessary action, and according to that generator will generate the power. And this is known as automatic load frequency control. So this is the automatic load frequency control which is existed in every power plant, right? So this is the recent clarification given by the POSOCO, that is Power System Operation Control, which is the NLDC, National Load Dispatch Center. The event was happened in Mumbai. So basically, one thing is that there was a line loss. Means there is a power loss on two lines. One line is 400 kV Kalwa to Fadge line 2. It is got tripped due to R phase fault, right? So one 400 kilowatt line, and at the same time, that is at 10 hours, means at 10 a.m. another line is got tripped of 900 megawatt load. And at first 9:58 hours one line got tripped, another line is got tripped at 10 hours. So then what happened, the huge load was got dropped. As we know that load is decreases, then the generator speed has to be decreased, but it takes time. So speed is increases, then frequency increases. So frequency increases, then over frequency relay should tripped. But if it is tripped, okay, but if it is for shorter duration, then it will manage. But if it is for long duration, then it will result in grid failure, right? So next things, but the all these so here the total Mumbai load is around 2600, but the load drop around 1250. So presently the load is in there, means at that time the load was 1354. So this much amount load the generator has to provide. So the other generating station has to be stopped for time being, and the emergency load, that is a emergency load means what, this is a Tata hydro and gas generation that will taken into service, and they will provide this much amount of the power, and they will manage well, and they will manage well. They were managing well, and at the 10:05 all lines get restored. Okay, so This is the sequence of the event that was happening in Mumbai, and some main reason is that is load drop because of the conductor snapping. One line is get tripped, another one is the RFS fault. So both line is got tripped. So total around the 1250 load got tripped. As load decreases, frequency increases, over frequency relay operate, but it is not for the shorter period. So that will leads to the decrement in the generation, and whole as we know that there is a decrement in generation, so all the grids are synchronized, every generating station are synchronized with each and every distribution line, because it is integrated system, right? So one generator decrease its generation, that will affects to the other generation generating power, right? So it has to synchronize well in fashion, and for that frequency is responsible. Because of that, there is a synchronization problems happens and grid fails, right? This is the main reason for grid failure. Thank you for watching, and if you want more technical content in future, let me subscribe to my channel. Thank you.